In this video, we'll take a look at power series. So let's define one. A power series is an infinite series that has a center at C, and the notation is generally f of x is equal to n is from 0 to infinity of a series, and it's multiplied by this polynomial with center C n times. So you would get a sub n, and then you would get a sub 1. So you get a sub 0, and then a sub 1 times x minus c to the power of 1 plus a sub 2 times x minus c squared, and this would just continue. And x is a variable. For example, you might get a series like 1 plus x minus 2 plus 2x plus 2 squared plus 3x minus 2 cubed. Oops, this should be a negative, minus 2, etc. And this would be a power series with a center of 2. Now, it turns out that power series converge. Absolutely. When the distance that they are from the center is less than r, and they diverge when the distance from the center is greater than r. And so if you imagine we've got a center point on our number line C, if you go to C plus r or C minus r, there is a zone where they will converge absolutely. And there are other zones where they diverge. It's all about the center. Now, the tricky part is these endpoints. We don't know what's happening exactly at these two endpoints. It may converge, it may diverge. We don't know for sure. And so what we say is that every power series has a radius of convergence r. So there's a distance on each side of this c value that it will converge absolutely. And if r is actually really big, infinitely big, of course, then this function, this power series, will always converges absolutely. And if r exists at all, if it's bigger than or equal to 0, then it converges absolutely on that small zone and diverges everywhere else, as I stated above. Like so. So let's take a look at an example of this. So where does the power series described by n equals 0 to infinity of x to the n over 2 to the n converge? Well, the first thing we need to do is go and find the radius of convergence. And we can do that by saying, well, a to the n is x to the n over 2 to the n. And so the ratio is the limit as n goes to infinity of the absolute value of a to the n plus 1 over a to the n. And so you get the limit as n goes to infinity of x to the n plus 1 over 2 to the n plus 1. And that gets multiplied by 2 to the n over x to the n. That's like dividing by a to the n. And so this gives you the limit as n goes to infinity of a half absolute value of x, which just becomes a half absolute value of x. And so now I have my ratio, and this p-value will be less than 1 if the absolute value of x is less than 1, which means the absolute value of x has to be less than 2. Therefore, f of x converges if absolute value of x is less than 2, which means our radius is 2, and therefore it diverges otherwise. Now, I did notice before that we don't know much about what's happening at the endpoints, so our next step is to check what's happening at those endpoints. And so we do that by looking at what happens at when f is equal to 2. So n is 0 to infinity. This is 2 to the n over 2 to the n now. And so this is just like 1 plus 1 plus 1 plus 1, on and on and on and on. What happens at the other endpoint when the function's evaluated or the series is evaluated at -2? Well, we get -2 to the n over 2 to the n, which is 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1. And so both of these diverge. They do not converge to a single number. And so our function only converges if it is strictly less than 2 distance away from 0. Let's take a look at another example. So where does the power series described by f of x is equal to sum from n is 1 to infinity of -1 to the power of n over 4n times x minus 5 to the power of n converge? So we define our a sub n value to be this. And then we go and we find our ratio test, the limit as n goes to infinity. Again, we do a sub n plus 1 over a sub n, absolute value. So this is the limit as n goes to infinity. And now I get x minus 5 to the n plus 1 over 4 to the n plus 1 times n plus 1. And then I get 4n times n and x minus 5 to the n. And so this becomes, well, there's an x minus 5 that essentially just gets pulled out. And I get limit as n goes to infinity of the absolute value of n over, what is left here, n plus 1. So this and most of this cancel. So there's a 4 to the n left over. We already dealt with the other terms. And so we get when we actually cancel this properly, there isn't an n here. We get the limit as this goes, this piece here will become 1, the quarter comes out, so we get 1/4 x minus 5, absolute value. And so this p will be less than 1 if 1/4 absolute value x minus 5 is less than 1, which is x minus 5 being less than 4. And so if you think about the center being at 5, I can go 4 in each direction, so 1 and 9, and that will be the zone of convergence. And we can say that f of x converges absolutely on 1 to 9, and now we have to go and do endpoint checks. So what's happening when it's 1? Well, I get summation -1 to the n on the numerator, 4 to the n times n on the denominator, times -4 to the n, which becomes 1 to infinity of 1 over n, which we know diverges. And when I check what's happening at the other endpoint, I get the sum of n equals 1 to infinity of -1 to the n over 4n times n times, and now I get 4 to the n. And so this is similar, but now I get -1 to the n over n, and this converges. And so this new piece of information added up with this information tells me that f of x converges absolutely on 1, and now it includes 9.